Countdown.
Tahniah. Siaran langsung ini dibawakan khas kepada anda oleh Akademi YouTuber Malaysia. Sebuah inisiatif E-Didik Malaysia dan Kelab Guru Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Selamat petang dan salam sejahtera. Hai semua para guru, ibu bapa yang dihormati dan para pelajar yang cikgu kasihi sekalian. Selamat datang ke Pusat Akademi YouTuber, usaha sama E-Didik dan Kelab Guru Malaysia. Bermula percuma, selamanya percuma. Untuk mendapatkan keberkatan kelas kita pada petang ini, mari kita sama-sama mulakan kelas dengan membaca doa mengikut agama masing-masing. Apa khabar para pelajar yang cikgu kasihi sekalian? Harap semuanya berada dalam keadaan baik dan bersedia untuk meneruskan kelas kita pada petang ini. Cikgu percaya pelajar-pelajar dah tak sabar untuk mengikuti kelas kita pada petang ini. Cikgu memperkenalkan diri terlebih dahulu. Nama cikgu Teacher Tan dari Kolej Matrikulasi Selangor selaku moderator pada petang ini. Hari ini kita ada kelas tuition kimia pra-AYU. Pada petang ini, kita bersiaran secara langsung dari channel Cikgu Shahnon. Sesiapa yang belum subscribe Cikgu Shahnon, silalah tekan butang subscribe sebagai tanda sokongan kepada Cikgu Shahnon. Tajuk yang akan disampaikan oleh Cikgu Shahnon pada petang ini ialah Periodicity, khas untuk pelajar pra-AYU. Kelas ini akan berlangsung lebih kurang 1 jam. Bersama cikgu pada petang ini ialah Cikgu Rosmaya mengajar fizik dari SMJK Yuhua Selangor dan sebagai control host, dan Cikgu Teacher Aileen dari SMK Datuk Pegawai Timur Pasir Gudang Johor. Sebelum kita teruskan kelas kita, ingin cikgu ingatkan semua pelajar dan penonton yang ingin menghantar komen agar menggunakan bahasa yang sopan dan gambar profil yang bersesuaian untuk tontonan umum. Sila fokus pada isi pelajaran yang akan disampaikan dan hanya menggunakan ruang chat untuk menjawab soalan atau jika ada soalan yang hendak diajukan. Pada akhir siaran ini, link e-sijil akan diberi dan anda akan mempunyai 30 minit sahaja untuk mengisi maklumat. Pastikan menggunakan email e-didik sahaja ya. Cikgu percaya semua yang hadir pada petang ini merupakan pelajar-pelajar cemerlang dan marilah tunjukkan disiplin yang terbaik. Oleh itu, cikgu harap semua memberi sepenuh perhatian semasa kelas bersiaran. Tanpa membuang masa, cikgu serahkan kelas kepada Cikgu Shahnon. Dipersilakan Cikgu Shahnon.
Cikgu Shahnon, you didn't turn on your mic.
Cikgu Shahnon, dah boleh dengar Cikgu Shahnon? Mic mute.
Halo, halo,
Pelajar sekalian.
halo.
Ya, boleh dengar dah.
Halo.
Boleh dengar dah, boleh dengar dah.
Okey.
Boleh dengar dah, boleh dengar Cikgu Shahnon.
Okay,
Cikgu
Assalamualaikum
Shahnon mau
warahmatullahi.
mulakan dengan hebahan sekian.
Okay, our first code 7. Our first code is 7, 7. Itulah code yang pertama. Kita ada 4 nombor, and our first number in our code is 7. Okay, this is my poster. Every Sunday 3:30 p.m. Kimia Prayu. And this is my profile. My name is Shahnon bin Awi from College Matrikulasi Pulau Pinang. My teaching experience, 21 years old. My channel is www.youtube.com/Shahnon channel. And this is my teammate, my team, Kimia Prayu. Okay, we have Cikgu Mawa, Teacher Kong, Teacher Tang, our moderator, Teacher Vivi Liao, and Teacher Yi. And our teammate from mathematics, Prayu, led by Teacher Im, and we have Teacher Eileen. Teacher Eileen is our pemerhati today, Teacher Zanariah, and so on. And biology Prayu, led by Cikgu Faizah. We have Cikgu Fatia, Cikgu Naini, and Cikgu Wawa. And this is for accountant and economy Prayu, led by Madam Fizi. Okay. And ahli is Cikgu Yati, Cikgu Lee, and Cikgu Yi. And this is physics. Okay, led by teacher. But we have Cikgu Rusmaya here, our CH controller. Okay. All right. And this is our portal Academy YouTuber Malaysia, www.academyyoutuber.com. And we have many information from here. You can surf this portal to get more information. All right. Okay, before that, anybody can hear me? Oh, I have a problem with my headphone here. Teacher Tang?
Boleh dengar, tapi ada echo.
Echo, alright.
Yes, can hear you. Ada echo.
But you can hear me, Okay, good.
Echo. Boleh.
Okay. Okay, our topic today is periodic table. The subtopic is periodicity. And in this about 1 hour, I will explain about qualitatively the variation in atomic and ionic radius. Okay, cross a period from left to right, down a group, what happened to the atomic and ionic radius, and between isoelectronic species. Okay, the variation in atomic, usually ionic radius in isoelectronic species, and between the atom and its corresponding ion. Okay, actually the periodicity we have a lot of things we have to discuss, but in this 1 hour I'll focus on atomic and ionic radius. All right, only atomic radius or size. The size or radius of atom is difficult to be defined exactly because the electron cloud has no clear boundary. Thus, the atomic size, or R, is defined as 1/2 the distance between the center of two identical atoms that are chemically bonded with a single covalent bond. For example, we have here, let's say, let's say here we have oxygen here. This is atom of oxygen. This is atom of oxygen become O2. Okay, so to find the R, the radius, what we have to do is, this is the center of one atom oxygen, and this is center of one atom of oxygen, and then we can get the D, the distance. the distance between the nucleus of these two atoms. All right. When we get the distance, we know that the radius is half from the distance. So the distance divided by 2. Okay, the distance. So we can calculate the radius of the atoms. And then if you look at this D here, D actually also the bond length. Okay, this is the bond length between these two atoms. Okay, the D also bond length of these two atoms, and also the not diameter, the length. And then we can get the R. Okay, this is how scientists calculate the R of atoms. Okay, this is predictable. The size of elements in periodic table. We have hydrogen here, lithium, and so on. If you look at here, this is period 1. We only have 2 elements, hydrogen and helium. Here is period 2. We have lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. If you look at this, we can see that when cross a period, what happened to the atomic radius? Become smaller. Okay, smaller. Okay, look at period 3, from sodium to argon, also becomes smaller and smaller and smaller, and so on. Okay. The second one is we look at when we down a group. Okay, down a group from top to down here. We can see that from hydrogen to cesium here, the size become bigger and bigger. All right. Okay. So now, case 1, we have I think about 6 cases. Okay, 6 cases here. Okay, the case number 1 is when we cross the period and we take period 2, for example. Period 2, we have a lithium, beryllium, boron, oxygen. After boron is Liber, carbon. Here we have carbon, nitrogen, oxygen, fluorine, and neon. Okay, we have. Okay, this is a proton number. Okay, proton number. Lithium is 3, beryllium 4, boron 5, and so on. Carbon 6, nitrogen 7, oxygen 8, and so on. Okay, when we cross a period, we know that the number of shell in period 2 is 2. Okay, the number of shell in period 2 is 2. Number of shell in period 3 is 3, something like that. The number of shell in period 4 is 4. Okay, you already know if you learn chemistry before this. Okay, this is the number of shell. That means no different in the number of shell. But what happened to the effective nuclear charge? ZEFF here is effective nuclear charge. What is effective nuclear charge? Effective nuclear charge is in terms of mathematics, proton number. The proton number here, 3, 4, and so on. Proton number minus inner electron. Okay, inner electron. So the effective nuclear charge of lithium is 1. Effective nuclear charge of beryllium is 2. Boron is 3. Oxygen is 6. And fluorine is 7. Okay. How to calculate this? The same thing. Actually, you have learned it before this. After this. Okay, this is effective of lithium. And in a periodic table, actually the effective nuclear charge we can see from the groups. Periodic table, it has a group. Okay, actually lithium is group 1. Group 1, it has 1 valence electron, and actually the effective nuclear charge of group 1 is 1. Beryllium is in group 2, and the effective nuclear charge also 2, because the proton number minus the inner electrons become 2. Okay, and so on, like this. All right. So the reason why the atomic radius decrease when we cross a period from lithium until fluorine, okay, until fluorine here. Why? Okay, this is the reason. As the proton number in effective nuclear charge increase, as we can see, the proton number increase 3, 4, 5 until 9. And the effective nuclear charge also increase 1, 2, 3, 6, 7. The effective nuclear charge increase in the same number of shell. Okay, the net positive charge acting on the valence electron, or we call it electrostatic attraction, would progressively increase across the second period. Okay, this is the second period because the effective nuclear charge increase. That means the attraction of nucleus towards valence electron becomes stronger. As a result, the outer shell are attracted more tightly and pull more closely to the nucleus. That's why the size of fluorine, okay, fluorine here, the effective nuclear charge is 7, bigger than lithium. Lithium is 1. That means the nucleus the attraction of nucleus towards valence electron of fluorine stronger than what happened in the attraction of nucleus towards valence electron in lithium. Okay, that's why the atomic size shrink from lithium to fluorine. Okay, this is case number 1 when we cross a period. Okay, we look at the second case, cross a period, but in this case in transition metal. Okay. Transition metal is happen in from period 4 and above, period 4, period 5, period 6, and so on. Okay. Okay. For example, we have titanium, vanadium, chromium, after that manganese, and so on, until zinc. Okay, this is period 4. Okay, period 4. We look at the nuclear charge. Okay, the nuclear charge of titanium, we look at the proton number 22. Okay, 22, no problem. 23 for vanadium. For chromium is 24, no problem. In this case, we have to look at the valence electron of transition element. Okay, 3D2, 4S2. Okay, this one 3D3, 4S2, 3D5, 4S1, and so on. Okay. Okay, what happened here? In transition element, according to Ahbau, yes, we have to refer to the topic before topic periodic table. According to Ahbau principle, when we add electron, we have to add electron to orbital S first and then orbital 3D, even though the 3D orbital actually inside the outermost orbital is 4s. 4s is outermost, but when we add electron, we add 4s first, and we after we add 4s, and then we add 3D. Okay, we can see from here the 4s here, and then here it's become 3D3. Okay, here is 3D2, and then we add the 3D3. But in case of chromium, we have what we call anomalous case. The 4s is not filled completely. We fill it only one. We fill it one, and then we fill it to the 3D5. We have to discuss in other chapter for chromium. But the most important thing is we add to the 4s and then we add to the 3D. Okay, Teacher Tang? 20 minit?
Cikgu Shahnon,
Ya.
hebahan pecahan kod kedua.
Oh, pecahan kedua. 9. Okay. 9, if I'm not mistaken. Is it true?
One.
I don't
Huh?
think so. I don't think so.
This is all. Okay, let me see.
One.
Yeah, one.
One.
All right. Okay, one. Okay, one.
It's a one.
Okay, one. All right, betul. Okay, the second code is one.
Okay.
Okay, I repeat. The second code is one. Okay. The first code, no,
Okay.
I cannot tell. Okay, the second code is one. Okay. All right. The reason. Okay, this is the reason. Okay. The reason is nuclear charge. If you look at the nuclear charge, the nuclear charge is increased 22, 23, 24, and so on. Okay, no problem. The outer shell electron are attracted more tightly and pull more closely to the nucleus. This is what happened if the nuclear charge increase. Of course, the charge is the charge is positive. The electron is negative. It will pull the negative, right? The nucleus will attract the electron, and then because it is increased, of course, the attraction become stronger. Okay, but what happened here is we have what we call shielding effect. The shielding effect also increase. What is shielding effect? Increasing electron in the inner shell. If you look at here, when we add electron, the electron is add to the inner shell. Okay, inner shell. This one is 2, and then this one is 3. That means the inner shell is increased. The outer shell, this is outer shell. This is outer shell. And then when we add electron to the inner shell, it will shield the attraction of nucleus toward the valence electron. Okay, that's why we call it shielding effect. Okay, shielding effect or screening effect. Okay, we can call it shielding effect. We can call it screening. Okay, screening effect. It will shield because the nucleus will pull or will attract the valence electron, and then we have an inner electron that will shield the valence electron to be pulled from the nucleus, right? So we look at here. Where is this one? The outer shell electron are repelled further away from the nucleus. In this case, we have nuclear charge will pull the electron, and the shielding effect will make the electron will repel further. So we have two effect here. Number one is try to shrink the nucleus, no, the size, and the second one, the shielding effect, try to expand the size. So this will cancel each other. Okay, the charge is cancelled by the shielding effect. Okay, the nuclear charge and the shielding effect will cancel each other. That's why the atomic size show no significant change. In transition element or transition metal, we can see that we cannot see the significant change in atomic size, right? This is the case number 2 when we cross a period, all right? Number 1, without transition element, period 1, period 2, and period 3. And when it's come to period 4, period 5, we have a transition element. The transition element, there is no significant change in atomic radius. Okay. All right. Case number 3. Case number 3 is down a group. Okay. And we take one example of group 17. We have 18 group 1, group 2, group 3, and so on. And in this case, we take group 17 because this group very familiar to us. It starts from fluorine, chlorine, bromine, iodine, astatine, and so on. Okay. If you look at the number of shell, of course, fluorine at period 2, the number of shell is 2. Chlorine at period 3, the number of shell is 3, and bromine at. So they are in a different shell. Okay, They are in different shell. And if you look at the proton number, the difference in proton number quite large, 9, 17, 35. Okay, the difference in a proton number quite large, but look at the electronic configuration. Econs is electronic configuration. This is period 1. Period 1, we has 1s2, 2s2. This is period 2 lah. Okay, 1s2, 2s2, 2p, 5. Okay, that's what we have. 2 here and 7. This is 2s2, 2p5. So 7. This one, okay, 1 until period 3 here. This is period 1, 1s2, 2s2, 2p6, 8. And then we have 3s2, 3p5. Okay, if you look at here, the electronic configuration, here we only have 1 and 2, 1, 2, and 3, and this one, of course, become larger and larger. Okay, orbital size increase with the increasing principal shell. This is number of shell or principal. Before that, we know that this is principal quantum number and so on. Increasing principal shell, this is 2, 3, and so on. So the orbital size, we already know that orbital 3 bigger than orbital 2. Okay, orbital 3 bigger than orbital 2. Orbital 2 bigger than orbital 1. This one we have orbital 4. Orbital 4 bigger than orbital 3 and so on. Because of that, the orbital size increases with the increasing principal shell. The increase in shielding effect. So shielding effect also become larger. And then the increase in nuclear, and we know that the nuclear charge also increase, 9, 17, and so on, right? The nuclear charge also increase, but it cannot. But the shielding effect, the effect of shielding effects are quite large. Okay, quite large, leads to decrease in effective nuclear charge. Because of that, the nuclear charge, we can say that we cannot use effective nuclear charge to determine the atomic radius. Okay, we cannot use that. When we down a group, we just look at the shielding effect. Okay, the attraction between the nucleus and the electron cloud get weaker. Okay, even though we know that the nuclear charge bigger, this one, 17 and 9, but we cannot use this one. The attraction between the nucleus and the electron cloud gets weaker because of the principal quantum number bigger, the orbital size bigger, the shielding effect bigger, causing the size atom bigger, and so on. Because of that, the atomic radius of when we down a group become bigger. All right. How many now? I think maybe we can stop for a while. 30 minutes already, isn't it?
Okay. Yeah.
Okay,
So shall we stop for a break?
Okay, stop for a break for a while. Okay.
Berikutan pengumuman penutupan sekolah sehingga akhir persekolahan. Pengajaran dan pembelajaran secara home-based learning tetap diteruskan. Oleh itu, kami di Akademi YouTuber menyediakan tuition online percuma pertama di Malaysia, dari prasekolah hinggalah ke sekolah menengah, dengan kerjasama E-Didik Malaysia dan Kelab Guru Malaysia. Kenapa bayar jika anda boleh dapat percuma? Bermula percuma, selamanya akan percuma. Manfaatkan peluang yang ada. Jangan tunggu lagi, startilah sekarang. Untuk maklumat lanjut, layari www.edidikmalaysia.com. www.akademiyoutuber.com.
Dibawakan kepada anda oleh Akademi YouTuber.
Okay.
Cikgu Shahnon, you may continue
Yeah.
the class.
Okay, we continue our class with the code. Code rahsia lagi. Code rahsia. Okay, the third code is, let me see. Okay.
Cikgu Shahnon, 40 minutes only announced. Not yet.
Oh, belum. Oh, no, yeah. Okay.
40 minutes only announced.
Oh, tak sabar.
Yeah, not yet.
Okay. Okay, we continue. Okay, you will remind me. Okay, we continue. Case number 4. Case number 4, we call it isoelectronic species. Okay, what is isoelectronic species? Atom or ions of different element. Okay, must be different element means different proton number that have the same total number of electron. We call it isoelectronic species. Okay, same electronic configuration. For example, we have nitrogen here. Nitrogen has 7 proton number, oxygen 8, fluorine 9. So this is different element. Okay, and then nitrogen, when we add 3 electron, now the total number of electron is 10, right? 10. 7 plus 3, 10. Same goes to oxygen. Oxygen is 8 plus 2, 10. 9 plus 1, 10. Okay. Neon is 10. Sodium is 11. The proton number is 11. Plus mean we remove 1 electron. So 11 minus 1, 10. This one also 10, 10, 10. Okay. Different element that have the same total number of electron or electronic configuration. We call it isoelectronic species. Okay, how to determine the atomic radius? In this case, ionic radius. We call it ionic radius because this cation and anion, except for neon. Okay, look at here. Okay. Okay, all the electronic configuration for this species is 1s2, 2s2 to be 6. Total up, we got 10. Okay, 2 plus 2 plus 6, 10. We call it isoelectronic species. Okay, and then look at the number of shell. The number of shell, 2. How do I know? Look at here. Number of shell, because the last of electron is field at orbital 2p here. 2. See, number of shell is 2. Okay. Now we have a same number of shell, same number of electronic configuration. What happened to the effective nuclear charge? As we know that how to calculate the effective nuclear charge is proton number minus inner electron. Okay. For nitrogen, the proton number is 7. Okay, 7. And what is the number of inner electron? The number of inner electron here is 2. Okay, because this the shell 2 here become outermost shell. We call it outermost shell ataupun valence shell. Okay, the valence shell is 2. So the inner shell is S, and in 1s we have 2 electron. So 7 minus 2. 7 minus 2, 5. Okay, 5. And for oxygen, 8 minus 2 becomes 6. For fluorine, 9 minus 2. So from effective nuclear charge, we can see that the silicon here, the ion silicon here, where is my pen? Okay, let me. Okay, this is my pen. I want to change with highlight. Okay. Yeah. Silicon here, the effective charge is 12. We already know that uh, the larger the effective charge, the stronger the attraction or the electric forces of nucleus towards valence electron. So the atomic the in this one is ionic. Okay, the ionic radius will shrink, will become smaller. So from here we know that from N3 minus to Si4 plus, Si4 plus here, Si4 plus has the smallest in ionic radius. Okay, this is the reason. The proton number effectively charge increase. We already know that. From here we can see 7 to 14, and also the effective charge also increase. Electrostatic attraction increase, so the in this case is ionic radius, except for neon. Neon is atomic. The rest is ionic, become shrink. Okay. All right. This is case number 4. Okay. Now we look at this graph. Y is ionic radii and X is number of proton. Here we have from Na plus, Mg2 plus, Al3 plus, and Si4 plus. All right, and then we have this is period 3. All right, yeah, this is period 3. Okay, from sodium to chlorine, P3 minus. This is the ion and anion. Okay, in period 3. If you look at this from P phosphorus, P3 minus, S2 minus, and Cl minus, the electronic configuration are the same. So we call it this one, this what we call it, isoelectronic species. Okay, isoelectronic species. 1s2, 2s2, 2p6, 3s2, 3p6. Okay, for these 3. And the effective nuclear charge increase, of course, because proton number of chlorine larger than sulfur and phosphorus. Okay. In this one, the proton number minus this is the inner electron, because this one from 3s to 2p6 become outermost shell. Okay, this is inner shell. So electron in inner shell, we call it inner electron. We have 6, 10. We have 10 inner electron. The effective nuclear charge is increased, so electrostatic attraction also increase, and ionic radius become smaller. Okay, become smaller from P3 minus to S2 minus to Cl minus. All right. And look at this one from Na plus to Si4 plus. Okay. Okay. First of all, we write the electronic configuration: 1s2, 2s2, 2p6. In this case, this one will become inner electron. Okay, the effective nuclear charge increase from Na plus, Mg2 plus, Al3 plus, and Si4 plus. Electrostatic attraction also increase, and ionic radius will decrease. All right. Oops. Okay. The different here, if you look at from Na plus, Si4 plus, why we have a different size from here? Because of different in number of shell. Okay. From P3 minus to Cl minus, the number of shell is 3. Okay. Whereas from Na plus to Si4 plus, the number of shell, the outermost shell is 2. Yeah.
Okay.
Yeah,
Cikgu Shahnon, the third
yeah.
code. Yeah, the third code.
Okay, the
The
third
third
code. Let me see first. I think I still remember the code. The code is 9. Is it correct? Yeah, 9.
Yeah. Yes,
The third,
yes, yes.
the third code is 9. Okay, I repeat 3 times. 999. Yang telefon polis pula. Okay, 999. Okay, this is the third code. Alright. Okay. Why we have a different from Si4 plus to P3 minus? Because of we have to look at the what we call valence. No, valence. What we call it? Um, uh, we call it um, orbital. Okay, this is 3. This is only 2, right? Okay, case number. This one is case number 5. Okay. Now we have case number 5, atom and its corresponding ion. Okay, atom and its corresponding ion, we have 2 types. Number 1, we remove the valence electron. Number 2, if gain electron. Okay, we look at what happened when the atom remove its valence electron. For example, we have magnesium. The proton number is 12. Okay, and when it's removed electron, it's become Mg2 plus. It removes 2 electron, for example, but the proton number is still 12. Okay, we cannot remove proton. We only can remove electron. Yeah. Okay, the number of proton is 12. Okay, but the number of electron different. For atoms, we already know that atom should has same number of proton and electron. So the number of electron for magnesium atom is 12, but the number of electron in Mg2 plus is 10. Okay, we remove 2 electron, so it's become Mg2 plus. Now, which one? Which one has bigger in size? Okay, the answer is atom. It's magnesium atom bigger size. It has a bigger size compared to its corresponding ion. Okay, the reason is because same nucleus charge attract less number of electron, less repulsive between electron. For this one, for this one, because we have a same proton number, but for Mg2 plus, it will attract less number of electron, only 10. For atom, it will pull or attract 12 electron. So this one, the attraction between nucleus towards remaining electron, we can say something like that. The attraction of nucleus towards remaining electron becomes stronger. That's why the size becomes smaller. Okay, the size becomes smaller. The electrostatic attraction become stronger because same nucleus attract less number of electrons. Okay. Okay, this second one is addition of electron. We have a lot of example to show that uh, uh, for the formation of an ion. Okay, for example, in this case is chlorine. The proton number is 17. When it attract 1 electron, it's become Cl minus. It's become an ion. Okay, the same thing. The number of shell is the same. The number of shell they are in period 3. Okay, then in period 3, the effective nuclear charge still the same, 7, and the number of valence electron 7 and 8. So the reason is the repulsion between the valence electron because for Cl minus it has more electron, because the more electron mean electron will repel each other, and when it's repel each other, it will enlarge the domain of electron cloud. Okay, the repulsion between the valence electron. Okay, this one is 8, this one is 7. And this that's mean for 7 electron less repulsion, for 8 more repulsion. Okay, So it will enlarge the domain of electron cloud. So the size of anion for Cl minus bigger than its bigger than its atom. Okay. All right. This is case number 5. Wow. Oh, only 5. I thought 6. I thought 6. Only 5 things that we discussed for today. And this is some summary. Okay, summary how we want to know the ionic radius or ionic radius or atomic radius of element in periodic table. Number 1, we have to identify the differences. Okay, for example, if we, we have to know the number of field shell, field shell. That's why in this case, we have to know whether it is across a period, whether it is down a group, whether it is isoelectronic species, okay, something like that. We have to know that. We have to identify the differences, okay. And to do that, we have to know the field shell. Okay, field shells mean what period, the element in what period 1, period 2, and period 3, and so on. Okay. And then we also have to know the effective nuclear charge. And for the effective nuclear charge, this happen only when we cross a period. When we cross a period for atom or ion that cross a period, and for isoelectronic species. Okay, isoelectronic species and cross a period. So the effective nuclear charge are very, very crucial. We have to know. We have to calculate. And then we can determine the ionic radius or atomic radius. And also we also have to know the stability of half field and complete field. But in this 1 hour, I don't discuss about that. Okay, for this one. And electron repulsion. Yes, electron repulsion is when we add electron. It's happened in when we add electron to the corresponding atom. Okay, we have to know the differences, and then we also have to state the electrostatic attraction between the nucleus and the valence electron. This is very important. We have to state what happened to the electrostatic attraction, become stronger or become weaker. Okay, if electrostatic attraction becomes stronger, that's mean the size become smaller. If the electrostatic attraction between nucleus and the valence electron become weaker, that's mean the atomic size or ionic size enlarge. Okay, all of these will we only cover the size, but after this, with this one, electrostatic attraction, with number of field shell, effective nuclear charge, stability, and so on, we also can we can determine the ionization energy, electron affinity, and electronegativity from electrostatic attraction. Okay. All right. Okay. Okay. For electrostatic attraction, size become if electrostatic attraction stronger, the size will decrease, and ionization energy will increase, electron affinity increase, and electronegativity also increase. This we will discuss it later on. Okay, this is a summary for this 1 hour discussion. Is it 1 hour? Oh, we have a 20 minute. All right. 10 minute. All right. Variation in atomic or ionic size across a period. Okay, remember, across a period from left to right, what happened to the size? Decrease. Why is decrease? Because effective nuclear charge increase. Okay. Okay. Across a period, what happened? Across a period means from left to right. Okay, what happened to the atomic size? Will decrease. Right? Or descending a group. Okay, we down a group. The shielding effect. The shielding effect will increase. Because of that, the size also will increase. Okay? The size also will increase because of shielding effect also increase. And then for transition metal, no significant change. As I said, for transition metal means we have to cross a period. Cross a period. Let's say we take period 4. Period 4. We have titanium, vanadium, chromium, and so on. Because the nuclear charge and shielding effect will cancel each other. Okay. Transition metal, we cannot see significant in atomic radius or atomic size. Okay. And for an ion and its corresponding atom, this is corresponding atom. An ion, because it's gain electron, electron will repel each other, and then the size bigger than its atom. For cation, okay, we remove electron, so the attraction between nucleus towards remaining electron becomes stronger. That's why the size become smaller. It will shrink. The size will shrink. And then this is because of the total number of electrons different in total number of different, but still same proton number. Okay. So I think for today, this is periodicity with regard to the atomic or ionic radius. So thank you. I pass up to moderator.
Cikgu Shahnon, you want to tell them the fourth code?
Okay, the 4 code, yes, of course. The 4 codes. Let me see the 4 codes. I still remember. Number 1. Is it correct? The 4 code is number 1.
Oh, yes, it's number 1. Okay, yes.
Okay, what is the first code? Yeah, no one knows. The second, I don't know. Third, the 4 code is number 1. Okay, I think the CH controller boleh bagi apa tu? Link-link yang sepatutnya. Okay.
Okay. So, terima kasih Cikgu Shahnon. So, selesailah kelas kita pada petang ini. Ya. So, tahniah diucapkan kepada semua yang sedia bersama kita pada petang ini dari awal sehingga ke akhir siaran. Sebelum saya tamatkan kelas petang ini, dipersilakan Madam Rosmaya, you have anything to say? Sepatah dua kata? Madam Rosmaya, you need to on your mic.
Okay, pelajaran kita pada hari ini daripada Cikgu Shahnon telah disampaikan dengan amat baik. Jadi harap semua pelajar dapat tekan hit the subscribe button, okay, down here, and like, and don't forget to comment. Okay.
Okay. So, Teacher Aileen, dipersilakan berikan sepatah dua kata.
I think the topic just now was very interesting. But if you have already missed some part of the lesson, you can scroll back later on. Right.
Okay. So sebelum kita tamatkan sesi siaran langsung hari ini, mohon tutup ruangan chat dan klik button subscribe dan aktifkan ikon loceng supaya kamu tidak terlepas sesi kelas yang seterusnya. Sekiranya kamu suka apa yang anda pelajari hari ini, sila klik like and share kepada rakan-rakan anda di media sosial anda untuk sebarkan ilmu dan peroleh kebaikan di atas perkongsian tersebut. Sila type dan di ruangan komen sebelum link sijil diberikan sebagai tanda terima kasih daripada Cikgu kerana kehebatan anda menyertai kelas tuition percuma pada hari ini. Link sijil boleh didapatkan pada bahagian chat. Sila ambil perhatian, link tersebut akan tamat tempoh setengah jam selepas live ini. Pastikan anda guna email e-didik sahaja. Kesalahan memasukkan email tidak akan dilayan. Kelas seterusnya untuk subjek kimia pada hari dan waktu yang sama minggu hadapan. So, Ahad 3:30 petang. Jangan lupa juga dapatkan jadual terkini slot guru-guru AYU yang akan dikemas kini di Telegram SMS AYU dan website bit.ly SMS AYU. Jangan lupa juga untuk mengikuti kelas seterusnya pada hari ini, iaitu anda boleh rujuk kepada jadual. Anda juga dijemput untuk ke portal www.academyyoutuber.com untuk mendapatkan info terkini dan bantu cikgu untuk sebarkan kelas tuition percuma ini kepada rakan-rakan dan guru-guru seluruh Malaysia. Usaha ini adalah hasil gabungan guru-guru seluruh Malaysia untuk semua para pelajar seluruh negara, terutamanya dalam menghadapi saat geni melawan pandemik COVID-19 sekarang. Semoga kita mendapat manfaat daripada kelas-kelas yang dijalankan. Ingat, #bermula percuma, selamanya percuma. Terima kasih kepada semua penyokong Akademi YouTuber. So, doakan kami terus kuat dan bersemangat untuk membantu dan membangunkan pendidikan Malaysia. So, bye.
Tuition online percuma. Tuition online percuma. Layari www.academyyoutuber bagi mengikuti tuition online secara percuma. Prasekolah, sekolah rendah, sekolah menengah, semua ada di Akademi YouTuber. Rujuk jadual di laman sesawang www.academyyoutuber.com. Semoga masa terluang anak-anak anda diisi dengan sebaiknya. Tuition online percuma, mestilah Akademi YouTuber.
Dibawakan kepada anda oleh Akademi YouTuber.